Anyways, I'm just gonna jump onto it. Guys, we are here with a sounding round of applause. I'm going to introduce Jonas first. So Jonas is a very he's a man full of wisdom. He's been in the computer vision space for 10 years plus. He's my boss. He's been he's been doing this thing for a long time. I met Jonas in Ghana when I went to Ghana to speak at PyCon Africa. And I just went like, hey Jonas, my name is Daniel. I'm an AI engineer. I do computer vision. I'm like, yeah, I do computer vision. I'm like, wow, because everyone that came for the conference were all like LLM guys. Everyone is doing LLMs. Like, man, no one is doing computer vision. Then I met Jonas and I told my friend Isabel from France, she's a professor, about Jonas. And she's like, oh, Jonas is a nice guy. It was the course lead, former course lead in Hugging Face. I was like, really? And the guy is just simple. Like, I remember the day we went out on speakers hangouts and I was just working with Jonas. We were talking, having conversation, and he was like, I was just there doing his thing. I was like, man, this guy is really nice and simple. So Jonas is a computer vision engineer, very good for that matter, and also a former course lead in Hugging Face. Hugging Face is the #1 computer vision community when it comes to the world at large. So he's going to be talking to us about computer vision from before I was born and how we managed to get to this step right now, this wherever we are right now. Yeah, please guys, just try to take screenshot of the sessions, post it, use the hashtags, and that is it for me. Jonas, you can take the stage and do your stuff. Thank you. Yo.
Thank you for the great introduction, Daniel. Yeah, I'm happy to be here. Sorry for the confusion with the time. That's usually the time zone stuff. It's always a bit messy. From experience, I know that. So yeah, of course, it's always a bit bad when the speaker is late. Usually the listeners are late. So, but yeah, I'm here now, and I've prepared a short history of computer vision. That's a topic I love to talk about. As Daniel said, I'm in computer vision for quite some time now. I think first I've got this about me slide. I mean, Daniel said quite a lot of stuff right now already. Right, I'm currently working as a data scientist at Celebrate Company. That's a company based in Germany. We're not doing very AI kind of stuff. We're mostly selling photo products and calendars, cards, whatever you can order on the internet. And I'm trying to make it a bit smarter with some machine learning. Mainly did NLP in the job actually, but I love computer vision, and that's what I did before. I did my master's science in computer science at the Technical University of Berlin, right? And I focused on computer vision there, and I worked in automotive systems research. So we did like autonomous cars and everything in a big research institute in Germany. And yeah, I like to go to conferences, right? Daniel also said I've been to the PyCon Africa, which was amazing. I'm still thinking about it often, and all the people I met, and I'm happy to have gotten a lot of connections from that. I also was at EuroPython like last year. Yeah, Abdul Samad. That's one of the connections, right? I mean, I could just talk about PyCon Africa for an hour now, but that's not what I'm here for. Yeah, I also like to go to other conferences actually. I've also been to like the Swiss Python Summit this year, so in Switzerland, which was like 4 weeks after the PyCon Africa, and I have to say the PyCon Africa was better, right?
Wait, is it because of the food?
Maybe because of the prices. I mean, Switzerland, oh God, I don't know. I mean, like buying one Coke in Switzerland is as expensive as just going for a whole dinner in Ghana, I think. So it's just like, yeah. But yeah, I also like the food. I like the fufu especially, right? I love fufu. Yeah, and I'm a Hugging Face fellow. That means well, maybe you know Hugging Face, the company, right? And they've got this fellowship program. where they invite people who do stuff for the community and then say, hey, you want to be a fellow? Then we've got this Slack channel and we can ask them whatever we want. We're just connected to the Hugging Face team. We're not getting paid by them or anything. We're just getting them some support, like first-hand support, right? We say, oh, we've got a problem here, we've got a problem there. Yeah, that's it. Okay, but now I think enough about me. Let's start. Yeah, with the overview, of course, right? So, like, yeah, I've prepared a little bit. So this is an old slide, right? I didn't prepare this slide, so I should have dropped like the 5th and 6th point because I'm not talking about Hugging Face today and the community computer vision course. That's from an old presentation actually. But I will talk about from Swift to AlexNet, the real beginnings, well, some of the beginnings of computer vision, convolutional neural networks, transformers, and most of all, multimodality in the end, right? But we start with a little comic. Maybe you know the XKCD web comics. They're really nice, really nerdy. And there's this one from 2014, right? And there's a guy standing next to a woman and he says, when a user takes a photo, the app should check whether they're in a national park. And the woman on the laptop says like, sure, easy GIS lookup, give me a few hours. And then the guy says, and check whether the photo is of a bird. Right, and she says, oh, I need a research team in 5 years. So the caption says, well, in computer science, it can be hard to explain the difference between the easy and the virtually impossible. So in 2014, the guy who drew the comic, it's Randall, and Randall is really a smart guy, and he knows like what was the state of computer vision in this year, right? And it was really hard actually to just say, is this a bird or is it not a bird in 2014? Okay, so now we're in 2024, and probably you haven't heard, but there was this thing released by Swarovski Optic AX Visual thing. It's binoculars, smart binoculars, actually. And you can take photos, videos with it. You can even share your photos, videos via app. And what's the best, I think, the best feature of this stuff, I don't want to sell it, but it's really cool. You can actually classify over 9,000 animals with binoculars, right? Just by looking at it and pressing a button, you can just say, oh yeah, that's like this kind of animal, or that's this kind of animal. So I wondered, okay, what got us here, right? It's like, I mean, it feels like a century, but it's only been a decade, right? It's like in 10 years, computer vision took a lot of steps forward. It just developed so rapidly. Yeah, that's just amazing. But we start from the beginning, basically, right? So when I started my studies in computer vision, that was in 2012, actually. And some first stuff we learned was key point detection, okay? So maybe one word about the image here. That is a bird, as you can see, right? Because we talked about birds before. And the bird is a Kia parrot, and it's native in New Zealand. And when I've been to New Zealand, I met some of these birds and they're really funny. So I just said, okay, now you are my favorite bird animal of the world. And yeah, that's why I'm using them here today, because they are my favorite birds. So however, let's say we want to detect whether this photo is of a bird, right? The first stuff we do is we detect key points. That means we try to figure out what is the important stuff in the image, right? What describes this image very well? How can we figure out this is a bird, maybe? Or like, yeah, we take a lot of pictures of birds, do a lot of key point detections on these bird pictures. And yeah, then we do clustering, right? And then we have got some clusters of our key points. And then we throw all that into some, yeah, for example, support vector machine, some classical machine learning stuff, right? And in the end, we get a classification which is very not accurate, actually. So it works like on really, really strange settings and just a few classes. But in the end, oh, well, it's not that good, right? Yeah, it works somehow, but not that well. So a next step, actually, that's one of my favorite computer vision algorithms, like of the old times, and that's Haar cascades. maybe someone heard of Haar cascades because they're still used sometimes today. And they were actually proposed by a paper by Viola and Jones in 2001. And what they did, they said like, okay, we created these features here, like white and black areas, you see that. And with these areas, we can basically calculate like, yeah, areas in the image, and we figure out, okay, a combination of these makes up an image in the end. And then they were able to detect faces in images. I think I've got a demo in the next one. Yeah. So there's like this YouTube tutorial here where you see that it's going over the whole image, and you see that it tries to match like these areas to the face, and wherever it scores like higher than a threshold, it just says, here's a face. So here there might be a face, here there might be a face. And in the end, it just checks, okay, now I've got a lot of overlapping bounding boxes. I'm just trying to like not make them overlap and just take one bounding box out of these. Oh, you can't see the slides. Can the rest see the slides? Or should I start from the beginning?
I can see your slide. I think
Okay,
person is having network issues.
that's good. Okay, all good. Thank you. All right, cool. And other trivia info about this image. Maybe you've seen this image when you did like computer vision tutorials. It's called Lena. Lena is not used much anymore, but in traditional computer vision, I remember in university when I did my bachelor's, we always had like this image of Lena, and nobody knew where it came from. At some point, we found out, actually, it's from Playboy in 1970s, 1980s or something. So it's just like this. They just cropped out like the rest of the Playboy image, of course. But yeah. um, yeah, I just couldn't find any other demo, but yeah, it's computer vision trivia, right? So the problems with like key point detectors and Haar cascades is that they are, you could say, really scared of stuff like generalization, flexibility, and robustness. So they're just really not good at that stuff, right? They work in the really constrained settings. They work okay-ish, as I said. I've got one story where I try to like train a car detector with just Haar cascades. And it worked if the time of the day was right, if there was no bad weather, and if the car wasn't too dark, right? That's like, okay, it worked for like white cars in sunny weather during daylight. And that's, yeah, kind of the way these old detectors worked. Of course, that's not great. And luckily, we got on with that, right? Especially in 2012, when we had the revolution, AlexNet, which is something you might have heard of as well, because that's what really kicked off our deep learning era right now. And AlexNet, yeah, here it comes. So that's the paper title, basically, right? ImageNet classification with deep convolutional neural networks. Yeah, first author is Alex Krzyzewski, second Ilya Sutskever from OpenAI these days, right? And yeah, then there's Geoffrey Hinton, who was probably supervising, and we probably know his name as well, one of the godfathers of AI, right? And yeah, it's a pretty interesting paper, because yeah, it just kicks off so much stuff. But there was already some neural networks and convolutional networks before that, right? So actually it started in 1979 with a Japanese guy who made the Necognitron, something I also never heard of before I investigated for this presentation. Then there was Linnet by Yann LeCun, another one of the godfathers of AI, right? Now he's at Meta, like the head of research, I think. I'm not completely sure, but I think it's like something like that. Yeah, in between there was still some more, and then there was like Linnet 5 by Yann LeCun, which worked okay-ish as well in 1998, but then AlexNet just blew all the rest out of the water, right? AlexNet shattered like the benchmarks, and everyone was like, wow, it actually works. Before the stuff was just somehow trying to work. And yeah, so I hope most of you have heard of convolutional neural networks and might have an idea what they're about. For the rest, here's a really quick overview. Like, so there's this image here. And first we start with our input image, and then we have like a kernel that is wandering over this image and just analyzes patches of the image, and then basically creates new matrices out of this base image, and then it just goes on like that. Yeah, so it just analyzes an image with what we call a kernel. Actually, here's like a 3x3 grid that is going over this image, right? And yeah, just analyzing again and again and again. And in the end, we have some neural network layers that are then, well, in the end, classifying or whatever you want to do with it, right? So it's like a really rough overview. And that's LINET 5, actually. So that's like 1998, Yann LeCun, he did this, and it just has like a few layers, right? There's like, okay, we have our input, then we get our first layer here, the convolutions, then there's a subsampling layer, pooling layer, and there's convolutions again, and there's subsampling, and then we have some full connection. So actually it's just two convolutional layers, some subsampling in between, and the full connection layer. That's like 3 real layers, I would say. Yeah. But then there was AlexNet, right? And AlexNet, actually, this is most surprising. This is the real original picture they used in their paper, right? They just cut off the top. And I was like, when I looked at this, I was like, wait, it must be wrong. That can't be the real image. But actually, that's what they used in their paper, in their landmark paper. They used this strange, yeah, cut off thingy here. Whatever. So AlexNet basically is 2 networks, right? So we've got one down here and another one up there. And then they introduce connections between the networks and everything. And we see, okay, we already get more layers than we had in the net. And this worked pretty well. We can't really talk about deep learning yet. Well, yeah, it is advanced machine learning, I would say. But getting to deep learning took some more time, actually. But it is already way better than Haar cascades, right? If you remember, like Haar cascades had these handcrafted features here they try to match. Now stuff that comes from AlexNet looks like this over here on the left side. And you can see, okay, there is some similarity in some of these features that AlexNet came up with. And the cool thing is you don't have to do it manually, right? You don't have to say, oh, I want like black areas here and white areas there. No, the model comes up with that, right? The feature engineering, that's what we call it, is done by the model. And it's done way better than any human could ever do it, which was like really the massive step forward. Because getting the right features is just really, really hard. Okay. And now let's see, what does AlexNet say about our bird, right? About our Kier. So I used the demo. Here's a Gradio interface. And I just said, okay, here is the bird picture. It's actually AlexNet trained on ImageNet data. And I said, classify this bird. And it says 37% sure that is a kite. Okay, it's not really a kite, but okay, AlexNet, you are now like 12 years old. It's okay if you weren't that good back then. So actually, I checked. You might say now, okay, maybe it just doesn't have the right classes or whatever it was trained for. But there are some parrot-like animals, at least. There are no Kiers in ImageNet, but there are parrots, so it shouldn't say it's a kite and not like water owl or hen. So apparently we need to get better somehow, right? So we need to go deeper. Okay. I hope you get this reference still from, I don't know how old this movie is, but yeah. Daniel, were you born when Inception came out? I don't know.
No, I'm not sure I was born.
Maybe born, but a toddler or something. Okay, so then what followed AlexNet was really like the convolutional neural network boom, right? A lot of networks came out. And 2014, it was like a lot of stuff happened. So Google and Net, for example, VGG, which is still used sometimes these days, ResNet, which became the most popular one actually, MobileNet, which was just focused on getting way faster results, EfficientNet, which is also, well, focused on efficiency, apparently. And one of the most recent ones in 2022 was ConfNext, right? And there are a lot more in between, of course. I just try to pick out some landmark papers, some stuff that's used often. And actually, here's a little overview. That's pretty cool. You can get it at paperswithcode.com. Down here, you can find the link actually. I think I will share the slides afterwards in the WhatsApp group, and also on LinkedIn probably, so you can just check the slides afterwards. So what you see here actually is like usage over time, right? So here you can see a proportion of papers quarterly who use this model. And then you can see over time, like coming from, I don't know, 2017 to 2024, you actually see that ResNet is, well, just the king, basically, right? VGG is somewhere down here. You actually see AlexNet is in orange, and you see AlexNet comes crashing down from 2017. Yeah, because, well, I mean, in 2017, it was already 5 years old, right? And now AlexNet is, I don't know, it disappeared basically in 2021. No one's using AlexNet anymore, right? So yeah, I think it's pretty interesting to look at this because I wasn't even sure that ResNet was the most used or most mentioned model in papers, but here it shows clearly. Okay, so let's try ResNet, right? Here's our Kia, and let's go with ResNet. Well, ResNet is 51% sure that this is a hen, actually. Only 40% it's a kite. So like kite is second place now, but still, I mean, hen is kind of a bird, but it's not like a parrot or something. So yeah, it got better, but still not perfect, right? So probably when ResNet came out, classifying a Kia was still really hard. But yeah, I mean, there were CNNs for everything by that time as well, right? And we could also find other ones that actually can classify this as a bird and even detect it. And you also have segmentation. And that's what I call like the three foundational computer vision things, right? Tasks, you can say. Three foundational computer vision tasks: classification, detection, and segmentation. There's a lot more like fine-grained stuff that branches from that basically. But when you're looking for like really like, okay, what's like the base of computer vision, I would say these three tasks are the thing. And yeah, you can see here different models used for it, right? For classification as VGG, ResNet, EfficientNet, Net, MobileNet, ConfNext. For detection, faster RCN, YOLO, which is still one of the most popular ones, right? I don't know, which version are we at? YOLO 9, 10, something like that. Single shot detectors, RetinaNet, and segmentation. You have like the full convolutional networks, masked RCNNs, deep lab, UNet. Yeah. And actually, so I'm not sure how much gossip I should do, but I always feel like, oh yeah, I've been in this field so long. You know, when like the first YOLO came out, I worked in research, and I talked to one of my colleagues, like an older one, like 30 years older than me or something. And we were looking for some object detection models that worked well. And I was like, hey, Helge, I don't know, but I heard about this strange sounding model. It's called YOLO, you know. And he was like, what, YOLO? What's that? What's this model? Yeah, and like the net it was trained with is called Darknet. What, Darknet? What's he doing? And yeah, and actually, so the creator of YOLO and Darknet, I think his name is Joseph Redmond. And by that time, he still had this web page up, and you could click on his CV, and his CV was themed in the My Little Pony style. So there was like colorful with unicorns and whatever. Yeah, and then I tried to convince my much older colleague that YOLO is a really cool model, even though his creator might be a bit crazy. Yeah, yeah, my gossip. Okay, let's move on from gossip to something more serious. Domains, of course, because domains are really important, right? When you work with computer vision, you probably have some domain you want to apply it to. All right, so mine for a long time was autonomous vehicles, for example. There's a huge field of medical imaging, right? They've got so much stuff going on. And well, it's basically, and whatever you can think of, you can use convolutional neural networks for computer vision. Yeah, and there might always be like fine-tuned special ones or whatever. Probably you are working in some of these fields or want to work in one of them or did a project that just had one of these going. Okay, but CNNs are not the end, as you know these days, right? But first we have to do a little detour into something not computer vision, right? NLP. So probably these days you know what NLP stands for. But if you would have asked me in like 2016, hey, Johannes, what does NLP stand for? I would be like, I don't know. I do computer vision. Why should I care about something called natural language processing? Yeah, but just here's the definition, right? Natural language processing is the discipline of building machines that can manipulate human language or data that resembles human language in the way that is written, spoken, and organized. Okay, very nice. From deeplearning.ai. Cool. And what happened in NLP was transformers, right? I had no clue about transformers until like 2020 or something. But there was this paper called Attention is All You Need from 2017, right? From like a Google team mainly. And yeah, I mean, today we know that was like shattering the whole machine learning world. And there were more papers. BERT, the original GPT paper, right? Yeah, and others like Roberta and stuff like that. So suddenly NLP became a thing after this Attention is All You Need paper. It became important and transformers became important. And NLP just, yeah, progressed rapidly, right? Up until the point until 2017, it felt like, oh yeah, they're doing some progress, but they're not really getting anywhere. So computer vision is way cooler because we're really getting stuff done here. We're progressing. Natural language processing, yeah, whatever. But yeah, really in 2017, it just changed, you know, and it was like, okay, what the hell are they doing over there, right? The CV people were wondering. Yeah, at least I was wondering as a computer vision person, like what's going on over there? What is this transformers thing? And I mean, the real magic of transformers probably is the self-attention, right? And if you've never heard about self-attention, here's a really, really quick and short intro. So let's assume we've got this sentence. It's called, I like Kia parrots. A sentence I can get behind. And you split this sentence in 4 parts. We call it tokens, right? And these tokens, yeah, just represent a part of this image, of this sentence, not image. Now, what you do for attention is that you put 4 values to each token. You've got like query, key, and value, right? Q is for query, key, and value. So we have query, key, and value, attributes, numbers, whatever you want, for each token. And then you use these to calculate attention, actually. So from every token, you go to another token, and then you can calculate a score, the attention score. And with this, you can actually figure out like what is connected or what like should be important together. In the end, probably you will learn that Kia and parrots often occurs together and that Kia and parrots somehow are related. Right? In the end, you get like this Z3. That's basically the attention score from this token. Okay. I mean, that's by far not a complete thing of self-attention, a complete description of self-attention. But But yeah, just keep in mind, we've got tokens, we've got query key value pairs, and we kind of set everything in relation to each other. Okay, that's like the gist of self-attention in transformers. So what happened then in 2021 finally was that there was a successful paper for vision transformers, right? Computer vision done with transformers. And it was called Vision Transformer. Now, the real name was like an image is worth 16 by 16 words, transformers for image recognition at scale. And they introduced what they then called the Vision Transformer, right? So it was a really creative name. But yeah, the Vision Transformer was introduced in 2021, again by Google team, right? Like the Attention is All You Need paper. And how did that work? Probably heard about the Vision Transformer, and maybe you know how it works. Basically, you get your image, like our Kia parrot here, right? We slice it up, not the parrot, just the image, and we get tokens. Just like in the sentence I showed you, we now get our 4x4 tokens, so like 16 tokens, put them here, then we put them into through some linear projection, which basically just means, yeah, we get numbers out of them, embeddings, right, to have them, yeah, in a nicer form for further progressing. And we have then 16 embedding tokens here, and a special token, the class token. Then we put all these tokens into our transformer encoder, and then we can learn. Right? Then we learn. In the end, we have like this multi-layer perceptron here on top, where we put all these learned tokens in. And in the end, we can classify by just looking at the class token. Okay, which value does the class token have? And then we can, well, learn with that. Again, really short intro to it. Important thing is to remember, okay, we are also tokenizing images now by just splitting them up. If you remember about convolutional neural networks, we had these kernels that went like all over the image. Now we just say, we just take these patches of images, and no, we don't do convolutions anymore. And then we put them into a transformer and can learn from that. So now we ask the vision transformer, right? We've got our Kia parrot image here. What is that? It says it is a lorikeet, which I learned is some kind of parrot. So the percentages are pretty low here, which is some error actually in the demo that I used. It should be higher actually. So it is pretty sure it's a lorikeet or a macaw, which is also kind of parrot. So vision transformers apparently are better at recognizing at least that this is a parrot, which is pretty cool, right? Now we can know it's a parrot. Again, I've looked at papers with code to see, okay, how did vision transformers develop over the last years? And you can see them in blue, actually. Right? And you see in 2021, it starts rising, and then it crosses the ResNet line somewhere around 2021, summer 2021, I would say. Right? It gets better. But then what surprised me when I updated this chart actually yesterday, I saw that it dropped again, like in recent times, which is interesting, and we'll talk about it later. But yeah, so apparently vision transformers experience a small drop these days. But yeah, you see it's more often used in papers than ResNet or any other model really these days. So yeah, of course, there are also a lot of transformers, right? As I said, like the classification, detection, and segmentation, the 3 tasks, and you have transformers for everything as well. So for classification, there's like the vanilla VIT, as it's often called, right? Then there's Swin, which is actually one of my favorite transformers because it introduces hierarchical thinking, a bit like convolutions into transformers, which helps when you have small objects, especially in or small details that you want to recognize in your images. There's state, there's masked autoencoders, and there's Dino, which is a pretty cool and helpful transformer. For detection, there's also different things, right? Like Deter, masked Dino, YOLOS, which is not really related to the YOLO model, but they use the name, I think, mainly for marketing purposes, and it works. And there's deformable data. And for segmentation, there's stuff like the sect former, mask former, and SAM. Yeah, SAM by Meta, which is one of the coolest segmentation models I think I've ever seen. Okay, so yeah, here you can actually see like another chart. You see that the vision transformer in red, right, is like the most used of this stuff, and the swin transformer in blue is also pretty often used. Dino is pretty popular as well. Okay, let's move on. Okay, so now we've got like CNN and transformers, right? And we are like, okay, they are like battling each other now for the best thing. Should we use like CNNs or should we use transformers? I mean, from what I've talked about now, you might feel like, hey, transformers are way better than CNNs. Why should I ever use a CNN in my work, right? And yeah, I mean, transformers, especially the last years, I mean, they feel like the modern stuff, but still there are good reasons to use CNNs, I think. For example, on the CNN side, we've got like parameter efficiency, right? So CNNs tend to be way smaller than transformer models, so they don't need that many resources to run them. On the other side, transformers are easier interpretable, right? So if you really want to know, okay, why did my model do what it did? Why did it say what it said, basically? It's easier to analyze transformers for that. CNNs, you've got local receptive fields, and for transformers, you've got global context. So for CNNs, they are still better at connecting like things that are next to each other, right? Because we saw that like, especially for the vanilla vision transformer, we just chopped up the image and then we, just take this one image patch and create like a set of numbers out of it. And the local receptive fields on CNNs is just way smaller and just way more detailed in looking at that stuff, right? So transformers, but are cool for their global context because you can actually get more relations over the whole image. Because in CNNs, it's hard to like connect the upper left corner to the upper right corner of the image. Yeah, I mean, that's pretty cool thing for transformers, that you have got this long range dependencies. That's what it's basically called. CNNs usually have a smaller training time than transformers, but transformers are way better at few shot adaptation. So when you don't have that many examples and you just take a pre-trained transformer, usually it's easier to get good results with a transformer than a CNN. CNNs on their side have the industry adoption advantage, right? Because CNNs have been around for like a decade now, and there are just a lot of companies that have been working with CNNs and where they build up like the whole ML ops pipelines basically for CNNs, right? So I mean, that's changing now because transformers are so popular right now. And on the transformer side, you have multimodality, which is what we will talk about next, multimodality, right? That brings us to our vision language adventures. So sometimes I like to create images with text to image models. Ideogram is a really cool one, actually. It's really good. Okay, so when we talk about multimodality, there's one model we cannot miss, and that's CLIP. So CLIP was proposed by OpenAI in 2020, I think it was. Yeah, should have been 2020. And CLIP basically introduces contrastive pre-training between text and images, right? So what they do is they have like a whole bunch of captions and a whole bunch of images. Then they use a text encoder to create like representations for each of these captions, like T1, T2, T3, whatever. Each one of these is a caption, right? And they use an image encoder to create representations of the images. Again here, right? And then say, okay, now we just want to learn like what is really similar. So they've got their labels, like this Pepper the Aussie pup is the first one, right? So they say, oh yeah, this one is very similar. And then in the end, They just have like this, this massive amount of images. Because it's OpenAI, we don't exactly know what the data set was they used for it and how permissive that was, but it was like, yeah, just massive. And then in the end, what they can do with it is, for example, they can do zero-shot predictions, right? Like we've got this image of a dog here, and then you put in some labels and try to figure out, okay, what is it actually? Okay, and it is pretty good at saying, it's a photo of a dog. So what if we put this in our Kia and we give it 3 words like parrot, kite, or coconut? Which one is it, right? It's pretty sure it's a parrot. So here we actually have 2 outputs. The first one is clip. The second one is cyclip. Again, the percentages aren't good here. I don't know. Yeah, so clip is really sure it's not a kite, which is good compared to what we saw in the early CNN days, right? And cyclip, actually, that's the most modern. It's currently, I think, the state-of-the-art clip-like model. So it just took like the ideas of clip and took it to a different level right now. So cyclip is in most benchmarks way higher than clip. If you ever want to use a clip-like model at the moment, I would say use cyclip because it's pretty good actually to use. And yeah, but here we see, like, again, our papers with code graph, right? It sees clip rising way higher. I mean, the comparison here is a bit strange. So I can't choose like what to compare it to. It just has these graphs on the papers with code side. So ignore the other ones here. But I can tell you that the vision transformer actually is now below the clip line, right? We saw the vision transformer like, going down, and that actually didn't happen with clip. And I do think, and this is like an educated guess, that this is related to clip being used quite a lot in multimodal models. And we see a lot of multimodal models coming out in the last months, last year, whatever, right? So clip is really important now. If you want to understand multimodality, it's good if you start with clip as like the first idea. Okay, but there's not only clip, right? There's other models. For example, Owlbit. Owlbit is pretty cool because it actually can detect stuff, not only classify, as we saw in clip. So again, we have our text transformer and a vision transformer, right? Similar to clip, basically, the first part up here. And we just put in some words like giraffe, tree, car, and we put in our image. And then we get like predictions for each token, but we also get region proposals. And that's actually bounding boxes it can detect, right? And you can just put in whatever, right? So again, I used my Kia here. I said, okay, text query is a parrot, a kite. Detect how many kites you find and how many parrots you find. And it says, there's a parrot. That's pretty cool. And it's actually also pretty good at detecting stuff that it was not especially trained for, right? So this zero-shot object detection, that's Owlbit and Owlbit2 is pretty good at that. Okay, but yeah, okay. One more word about that. I mean, what we saw here is that we have like a text, like 2 transformers basically, right? Working together, a text transformer and a vision transformer. But we all know that we live in a large language model era now, right? I mean, large language models are the stuff everyone uses. And there are multimodal large language models. So maybe just to clarify, I mean, multimodal is more than one modality, really, right? Multimodal can be, if it's just text and image, it can be text and audio, it can be image and audio, it can be text and image and audio and video or whatever, right? As soon as it's like more than 2 modalities, it's multimodal. Okay. So basically the main structure of multimodal large language models is as you see it here. You've got some input, like here, some modality other than text. like audio, video, image, whatever. You've got a modality encoder, which then is like a vision encoder or an audio encoder, and you've got an input projector, right? So we've got our first embeddings from the modality encoder, then we have to project it to a way that we can actually feed it into a large language model. And we also feed in text to large language model, right? And then we basically use these tokens and give it to some large language model. There are some here: Plan, Llama, Vicuna, Qwen, Magneto. And in the end, there can be different outputs, right? Like one of the most common outputs is just text. We see more and more multimodal large language models with more outputs than just text. So when you have audio output, video output, image output coming from your large language model, right? Okay, so that's the basic structure of multimodal large language models. That's what they mostly have in common. And it's actually a pretty cool survey. I linked it down here. You can have a look at it. And yeah, if you want to know more about multimodal large language models and get into it, there's a lot of cool ideas. Yeah, good overview actually from there. Okay, so one of these large language models is Qwen2VL, right? And it can do a lot. So Qwen2VL can do, yeah, just chatting, can math encode, live chat, formula recognition, right? OCR stuff, multilingual OCR, long document understanding, video understanding, UI interaction, just a lot of stuff. How it does it is, yeah, basically as we saw before, right? So we've got like our input here, we've got a vision encoder, and then we put our vision tokens into the Qwen language model decoder, and in the end we get our output tokens. Yeah, what's so special about Qwen is that actually it can handle all kinds of resolutions. That's why it shows so many different images here of different resolutions, because it says like, yeah, give us any image, we can work with anything. We're good at low resolutions, high resolutions, videos, whatever. Throw in what you want, which is pretty cool, right? And yeah, I mean, here I've got my Kia, I've got the Qwen2 VL 7 billion model, so it's like with 7 billion parameters. And I say, yeah, please give a detailed description of the image. And it's, oh, wait, no, oh God, now it just read everything. Okay, the animation is broken, but there should be this thing disappearing. Let me check. I just delete it and we will see it. Here we go. The output text is: the image depicts a Kia, a species of parrot native to New Zealand. The bird is standing on a flat surface. Oh God, I can't speak anymore. It's too late here. So you can read the rest if you want, but it's just a lot of text, right? And it's really detailed explanation of this one image, which is really cool. I mean, now we can just use images and tell our models what we want to have with it. Like, is there a bird in the picture? Yes or no? And that's good. But I mean, what's even cooler than describing pictures with MLLMs is detecting objects with MLLMs, right? So of course there are options for that as well. Like, for example, Cosmos 2, which is another model which was proposed by Microsoft. It was just really released middle of this year, I think. I think the paper was way earlier, but they only released it middle of this year. And it can not only describe the image, but it can also tell us where parts of this description are in the image, right? Here, like, the eagle is a large bird with a black and white body and a yellow beak. And you can see like the eagle is marked here and the yellow beak is here. So you can actually get a cool description and the boxes where they are in the image. That's pretty handy. We can do that with the Kia as well, of course. So here I just said, okay, just give us a detailed caption. And yeah, that's what it gives us, right? A Kia parrot, a road. So it says, describe this image. A Kia parrot stands on a road with its beak open. And I said, okay, a Kia Parrot is here, a road is down there, and its beak open is over there. Yeah. So when models can do that, we talk about grounded multimodal large language models actually, because like their descriptions or their output is grounded in the actual image, right? They check if the stuff they want to talk about is really there. That also helps to mitigate hallucinations. If people saw my PyCon Africa thing, yeah, hallucinations are quite common, and like using grounding models can help actually in mitigating hallucinations. Okay, so we saw vision transformers and large language models are a great pair, and yeah, it's just going to the moon, right? But you know, LLMs everywhere. Sometimes I'm not happy about LLMs. You know, LLMs can be really hard. You can't really control them that well for their output. You often have trouble deploying them. Just really putting them into production can be really hard. They have their drawbacks. Luckily, there are also cool new advantages in computer vision that don't really need large language models, right? And one of those is Florence 2, also by Microsoft actually. And Florence 2 is a model that can do a lot. So the people behind Florence 2, they created a huge data set. This over 5 billion annotations, basically. And they said, okay, what if we just try to annotate for a lot of tasks, right? They yeah, just did a lot of work with all these tasks. They said, okay, let's create a lot of data for it. So this and that and that, and let's put it all in one data set. And then with this one data set that contains all these tasks, let's train a model, Florence 2, right? And this is how the Florence 2 model architecture actually looks. And you can again see that there is image encoder, and there's visual embeddings, and there's text and location embeddings down here. And then you've got transformer encoder and transformer decoder. So it is similar to a multimodal large language model, but there's no large language model here, right? So the transformer encoder and decoder, I mean, you could always say, okay, it's similar to like a large language model, but it's way, way smaller actually. And the parameter count is way, way smaller as well. So yeah, it's way easier to use. I can actually run it like the base model on my laptop here. And that's pretty cool because it's still pretty powerful, and it can do a lot of stuff that we saw from multimodal large language models. And yeah, it can do it with just a fraction of the parameter count actually of most. Okay, I have to say Cosmos 2 that we saw before is actually pretty small itself. But yeah, I feel like Florence 2 is just really proving that you actually don't always need large language models, right? So I just had a lot of fun creating memes the last day. So, so you're telling me expressive data is all I need? Yeah, in a way, expressive data is all I need, because what it comes down to, even in the large language model era, is that the better your data, the better your model, and the better your results are. If you have shitty data, no way you can turn them into gold, really, right? So you should always think about your data. And I mean, the Florence 2 people thought about their data, and they have this crazy pipeline, how they created their data set. And that is, I mean, that's a lot of work, right? It's not like a one person job, where they have like the images, of course, right? The image collection of like, I think they started with 126 million images. And then they had some models that initially created some annotations for them. And then they actually use like annotators, aggregators, blacklists, whatever to filter. And then they have this loop of Florence 2 running to get better and better. And yeah, in the end, they get their fine annotations. So actually creating good data sets to train on is a lot of work, but it is worth it in the end, right? So I would say if you have a lot of time and you have to think about where to invest it in your machine learning project, I would always recommend to invest it into the data actually, because yeah, data is important. Okay, I think I made my point, right? So let's check. Um, yeah, I just laughed about my own pun up here, but yeah. Florence in the bird machine. Okay, so we've got this demo again here. Uh, um, so let's check, right? Florence 2, what does it say? Image captioning. There's the Kia parrot, right? That's pretty good. So similar to Cosmos 2, it is also able to detect our Kia parrot without a problem. The future. Okay. But before we talk about the future, maybe just a quick look back at what we started with, right? I mean, we started with our key point detections with AlexNet that thought our Kia is a kite just about 12 years ago. And now we're here and we can just say, like, I don't know, just tell me what is in the image. And it tells us, oh, there's a Kia parrot and standing right here. And we can even create way more info from this one image, right? If you remember the comic at the beginning, where I said, like, it's virtually impossible to do this, like to figure out if the image is of a bird or not. And now we are just way beyond that point. Yeah, I mean, it shows us how fast we were developing in the last years. And the future is maybe even crazier. Let's see. Maybe we're heading for a crash. Maybe we're heading for even more crazy developments. So what I found was this visualization, and that's pretty interesting. That's like from a paper that was analyzing the numbers of papers per month in the ML and AI archive papers, right? And you can see, like, from 1994, it just goes up like here in 2021. And I mean, that was before ChatGPT, right? That was before our LLM craze era, hype, whatever you call it. We already had this log scale growth actually in papers, but then the LLM came, and I'm not sure how that looks now, but I think we are well above log scale by now, and it's crazy, right? I mean, it's yeah, that's what I often feel like as a data scientist in the field. And probably when you start learning ML, you feel that even more, because you don't know where to start, and there's just new papers coming out again and again, and maybe this is cool, maybe that is cool, maybe this is cool, and you might wonder, what should I look at? And it's not always easy. I mean, I don't even know it, right? But I think over the years I got a bit better, maybe. I hope I got better, and I can just ignore quite a lot of papers. But sometimes they're just papers that look really cool, and I want to read them, and I've got like this whole stack of papers that I want to read, and I can't do it all. So I thought about, okay, what actually is some advice I could give, right? Because sometimes I feel like that's like the paper pie I want to read, right? That's what it looks like if I would dump it on a beach. Yeah, but then I just imagine, okay, what if the wind comes and just takes some of them away? Would I be like sorry for it? Would I be like, oh no, would I run after the papers? And would I jump into the ocean? Probably not, because I would think like, yeah, no, you know what? I've got so many more papers to read and so much more cool stuff that I can discover. Probably these 2 or 3 papers I didn't read, they don't harm, right? And in the end, the really important papers, that's what I found, you will always hear about them, right? You might not be the first one to have read them, but I mean, if you are on social media, if you're on, I don't know, X, LinkedIn, Mastodon, maybe even Instagram, I don't know, I'm not a big Instagram, but yeah, maybe TikTok even, you will hear about the really important papers, right? So I think you should never be scared of missing out on like the coolest or like the big landmark papers, because in the end you will always know, because people talk about it so much, because there are so many people in the field. You don't have to be worried about that. And I've got some examples actually, like here. Maybe you remember retention networks. That was just a few months ago. Retention networks were like this thing. Maybe you don't remember anymore, because, well, people on the web are not talking about it anymore much. And there's JEPA. Maybe you know JEPA. It is pretty cool, and I really like it. but not a lot of people are talking about it. So is it really important, right? Might be. Mamba. Mamba is actually one that people still are talking about, right? State space models. So that's something I would say, okay, Mamba. Yeah, Mamba is one I should know about. I actually don't know about it, but I should know about it. I should read it one day, actually, and that's like should go to the top of my paper pile to learn more about state space models, right? And then I mean, from the ancient times, basically, I remember capsule networks, which is a thing probably most of you never heard about. It was proposed, I think, 10 years ago or so. And that's one of the ones that just vanished, I think. There might be a few papers coming out each year that are talking about capsule networks, but they're just not important. And I don't need to know about them, right? And G-flow networks. That was a thing, I think, like 5 years, 6 years ago. Generative flow networks sounded really cool. And I was like, oh yeah, these new cool networks. You've heard about them? Nobody's talking about them anymore, right? So in the end, mostly it's really time that will tell which papers are cool. And I just want to tell you, you don't have to be too afraid of missing out. Okay, and I think this is the end of my talk right now. The key has come in again. Thank you. Thank you for sticking around.
Wow, bro, said a whole lot.
It is a whole lot, right? That's why I said I will share the papers, the slides, because it is a lot. I mean, yeah, it's been a lot of development over the last decade or so, ever since I've been in the field. Actually, when I started in my bachelor's, only in like the last semesters I learned about neural networks, and we also had to handcraft one of these hack cascades I showed you in the beginning. Handcraft one of them for one of our appointments, so we still did like hack cascades. That's how old I am.
That's crazy, man. Yeah, guys, man. I told you guys I don't know anything. Like I don't. I'm dumb. I'm dumb. Like I don't know anything in the AI space for you, bro. Glory be to God. I was in this session. I like. I think um 60% of the stuff you said is stuff I don't know about. Like those old papers, bro. I don't even care about reading them then. I hate reading papers, bro. I watch YouTube tutorials.
I mean, you can always use Notebook LM these days, right, to create a podcast for each paper, and then you just listen to the podcast. That's
Yeah, but it is when I got a job in a company that was doing robotics that and I do robotics, but this guy was talking about 3D robotics and the rest of them, and he was like shooting papers at me. I was like, bro, go read this paper. And bro, like someone gives me paper to read for 1 month, like 5 papers. And I'll be like, I can't read this shit. And I just go force myself, read it. And after reading, it was really interesting. Then when I got to the code, it was really nice. Like reading papers is a nice thing, but in Africa, guy, we just want solution. So, we don't have time to read paper. We are looking for money.
That's cool. I mean, one purpose of this presentation is to give you an idea, like, okay, what happened in the last years, right? And actually, what is it like? What could I look into? What could I start with if I want to do something? And what kind of models are there? What are like the important models maybe to look into, right? And yeah, I hope that gives some impression of
Yeah, like I'm really happy I joined the session myself because I wanted to make one of our comedy admins to manage the session and then maybe I'll go and work or sleep. But I was like, man, let me just do it. And like I've learned a whole lot, like a whole bunch of things. But funny enough, like you said, most of those papers right now are not even being used again. In the industry right now, what is being used is ResNet, Yellow V8, and the rest of them, what others are still trying to come up. Before you know, Google they'll remove last vision models and it will just scatter everything that people have suffered. Like all the papers, all the suffering, they'll just bring last vision models and to destroy everything. We'll all run. It's crazy. The AI space is crazy. Like it has just gone up in a few months. Wait, pause. Before I go, our next speaker is here. He's been doing programming for 40 years plus since the 90s, since I was not born. He's a web developer and he does everything in the AI space. He's been in AI, sorry, he does everything in the tech space. He's been in tech before HTML became a thing, before internet became a thing. His name is Daniel McMullen.
That's funny. Yeah, that's true. Yeah.
Yeah, for real. It's really crazy. So he's gonna talk to us in the next 2 weeks about web, just like what Jonas has done. He's gonna talk to us about internet and technology and how we managed to get to this point where we are and the way forward. Hey Daniel,
Oh,
yo.
hey, yeah, no, and just a little teaser. Like so, before the internet, I used to run a two phone line bulletin board system, a BBS, if you've ever heard of those things. So it's sort of a precursor to the internet of home computers talking to each other. All right.
Man, Madu. Guy, I'm still playing around with robbers then. Ting, 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 and pursuing masquerades in the village. I'm still walking around naked, pursuing masquerades in the village and running up and down, like, bro. So that's our next speakers, guy. Tune in. He's gonna tell us about a lot of things. Yeah, yeah, I'm back. So like I've learned a whole lot. Like I've learned a whole lot from this session. Like I'm really, really happy for you coming to talk to us. Hey, yeah. So if you have any question, I would appreciate if we can lift up our hands to ask questions. Please, it's very, very important. Probably you want to talk about what you've learned or what you've written down, you can just go ahead to talk about it. So we are just gonna be very, very fast about that because this is getting to 1 hour, 30 minutes since we started this call. Oh, blessing. Yeah, go ahead. Ask a question, blessing.
Hi, good evening, everyone. So my question is, for someone that is a beginner and doesn't know anything about AI, where can we find the papers to read? So that's the question.
So can you repeat? I just wasn't.
I said, for someone that doesn't know anything about AI, where can we find the papers to read?
Papers in general are on, or it's, so do you want to know where you can find papers in general or just papers to start with?
Papers in general, I don't know, papers about
Okay,
the AI models and all, like a website that they host them or
yeah.
something.
So mostly I've got these links here, like it's this one, archive.org, or you can also go to Hugging Face, of course. Now I have to say Hugging Face, right? This company I talked about. I mean, they've got this web page, and if you go over here in this drop down, there's this thing called Daily Papers. And I actually use it to just check, okay, which papers came out today, and you can also like go back here, like to like the last days or whatever. You can also search by title if you're looking for a certain paper. That's actually pretty cool, and you can also like it, comment on it, discuss the papers. Yeah, it's pretty nice actually when you want to be up to date with papers. So usually what I do is I wait like 1 or 2 weeks, and then I take one day and just go through the, like, the last 1 or 2 weeks to check which papers came out and just note some that might be interesting in the future.
Wow. Dahiru.
All right, thank you very much.
Yeah,
You're
you're
welcome.
welcome. That's why we are here. Thank you. Dahiru, go ahead. Ask a question.
All right. Hi. Good evening, everyone. Yeah. So great talk. I discovered a lot of models that might will be useful in my workflow. So one thing I find that these vision models do struggle with at times is processing videos. So like when there are continuous frames, right? It tends to, well, the description, as I find, is not very consistent. So do you know any models that are like good with that, or how would you approach something like detecting anomalies in a video, basically, right? Because something like shoplifting in a short video, right? It's an anomaly, and the details might not transfer between frames. So I'm like trying to pick your brain on how you would approach something like detecting shoplifting in a video. Thanks.
Mm. Okay. So I have to say I'm not a video expert as such, right? I've not worked with that many videos, or when I've worked with videos like for autonomous driving research stuff, we mostly worked on it by frame things. And maybe, so I mean, there are like vision language models or multimodal large language models like Quen that can take in, or I'm looking for Quen, wherever it is, it can take in videos, right? And you could ask it, but I mean, that would only be a prototype for me, because I feel like, yeah, most LLMs are good for prototyping, but in the end, when you want to get stuff to production, you need something more specialized, right? You don't need something that can do everything. You need something more specialized. And for this, I would probably go with something like action recognition, right? Because when you've got like this case of, okay, I want to detect shoplifting, I mean, you might have the problem of finding enough data to train an action recognition model that can actually figure out, now there's a shoplifting happening, right? Yeah, but as I said, I'm not a big expert in videos. It's just from my shallow knowledge, I would probably go with that. Probably there are more ways, but yeah.
Great stuff. Yeah, I have actually played around with Quen. So far, it's it's actually the best that I found, but it still does struggle with finding those little key details. Yes, but thank you. It's I'll keep on and share it on the group if I do find something awesome. But thanks a lot.
Absolutely. Please share it. Also, always interested. In general, I think there's a lot of great applications that are shared in the group as well. And when I was at PyCon Africa, I was also amazed by how much computer vision is still used actually in a lot of applications in your life. Because I feel like at European conferences, it even more is large language model centered, and computer vision is just like, oh yeah, somewhere in the corner. But yeah, it's really cool to see what you're all building with it.
Oh, yeah, thank you so much. So the next question we have is from Hook, and then we are going to take it from Salisu Yahaya. Hook. Okay, Salisu, you can go ahead. Can you guys hear me?
Yeah.
Yeah.
Yeah,
Okay, while we are waiting for both of them to unmute, please, I'd like everyone to take a picture of the session, post about it on
then while we are waiting for him, please, I have a question. While you were talking about
wait,
that you like
Salis.
you prefer watching videos.
Hey, hold on. So let's start the session and try to post about it, and let's all try to follow our social media handles, please. We really need it to. We are planning starting physical sessions, but they are really expensive to host, and we are trying to apply for grants and talk to some people. But I know we just started our social media recently. It is just last month I opened the social media account after guys were like, "Guy, do this thing. We need it. We need to go out there." And I'm like, "Man, I'm just doing this thing for fun." They're like, posting it through my net. We need a website. We need a website. We need LinkedIn. We need Facebook. And okay, let's just do it. And in one day, we created everything, and we just have 50 followers, and we have 800 plus people. Guys, come on, go follow it up, post it, post about the session, and get people to know about us. Yeah, we need some money to host physical events. And I don't want to charge you guys. I don't want to charge you guys for these sessions, for the boot camps now. Because I know people that have money, even if you have money, but it's not enough. It's not enough, guys. Salisu, go ahead.
Hello, Mr. Daniel. How are you doing? I
Fine.
really appreciate the effort, but also I want to thank our speakers for their time and commitment to attend this session. Mine is not a question, the rules. Can we get the slides after the session? Thank you.
Jonas, you want to answer that?
Sorry, I had a bit of trouble understanding. I think the connection was a bit shaky.
Okay. Is asking for the slide.
I had the slides. Yeah, I will share them, as I said, in the WhatsApp group, and also like on what did I say, on LinkedIn, on my LinkedIn as well. So afterwards, yeah.
Thank you, sir.
I will share.
Okay. Also, the session is recorded, and I'm going to share. I'm going to post the session on our LinkedIn. Hook, please, you can ask your question. I think we've got to be really fast so Jonas can go and I can go and work, please. So if you want to ask a question, don't raise your hand now and we are going to close it. Hook, go ahead.
Okay, thank you for the very wonderful presentation. I have benefited immensely from the presentation. Thank you. While you were talking and Daniel talked about him preferring to learn from videos, you actually suggested a channel where you can watch podcasts. Please, what channel was that, please?
You're asking about the notebook LM to turn papers into podcasts?
Yes.
Yeah,
The,
sure.
yeah, wait, I can show you, right? Notebook LM. Notebook LM by Google. It's actually pretty cool if you have a Google account. Yeah, well, come on. So you just basically drop some file into there. It's in German now. Sorry. I don't know. You're doing some German now. No, you can just get whatever paper. Oh, no, I don't find a paper. Let me get a paper. Papers.
Oh
For
man,
example, this
can you
one.
convert it to English?
Yeah, I will try. Wait, can I? Where can I switch? I don't know. Oh, I don't know. Anyway, when you upload the paper, you will get this screen. It's the same in English, right? And there's this thing over here, this box, and there you can say like generate. That's generieren is Deutsch, German for generate. You click on this, and it will actually create a podcast of two speakers that are discussing the paper I just uploaded. Here is Flexibit. Right, and you just wait a few minutes and then you get your podcast of, I don't know, usually it's between 10 and 15 minutes, and there are these two people talking about this paper. Then it's pretty cool to get like the gist of papers, if you don't want to read everything. Sometimes they're wandering off on some general machine learning questions, but yeah, it is pretty good if you don't have much time or just want to get some stuff in audio format.
Wow, this is crazy. This is mad. This is mad. Like, how is this even possible? Wow.
Yeah, that's the link, right? Yeah, thank you, Daniel.
Wow, Google.
Google.
I swear this is crazy. Like,
You know,
I'm trying to build a startup
um,
around something like this, but it's not in notebooks. It's about some language shit, but it's also close to this and it's as crazy as this. But this is I'll not talk again. Abdul,
Yes,
Abdul,
please. Yes.
go ahead.
I think you already asked, right? Abdul already had. Or,
No,
I think.
yes.
Oh, okay. A question about wood defects actually posted in channel, right? Like here. How I can get data for surface wood defects and what models would be best for this? Or how you can get data? That's always a good question, right? I'm not sure about the wood defects. Again, I can refer to Hugging Face actually, because they have this. I mean, if you go to Hugging Face website, they've got this data sets thing up here. And maybe you can find something for wood defects, but there also is actually, there's a data set search. I don't know how many people know that. I think it's a well-kept secret by Google, that they have this data set search where you can maybe easier find wood defect. I don't know. Maybe you find something in here. Wood surface defects on Hugging Face, actually. That's great. Dataset Ninja. Ah, yeah. See, Daniel, you also found something. So I think there are different ways, right? So there's like Hugging Face, there's dataset search. Oh, here's one, right? Is that the one? Probably. The one you posted as well, Daniel.
Me?
I don't know. I can also post it here. It's like this data set. So yeah, in general, a good starting point is Hugging Face or this Google data set search for me, at least. I didn't know Dataset Ninja. Also sounds cool.
Oh yeah, I think I've seen some data sets on RoboFlow, Cargo, and I'm gonna share the link right now.
Okay, cool.
Yeah, this one has up to 2,000 images. Yeah, you can go ahead, Jonas.
Yeah, there was more. There was also the question about models, which would be best for this. Well, that's, I guess, it depends on what you want to do with it, right? If you just want to classify that there is like a defect, and it's classification, a simple classification. I mean, for this, you could probably even use some ResNet, whatever CNN model, easy to deploy, easy to fine tune. If you want to do detection of these things, yeah, I mean, it does contain bounding boxes apparently, so you could use this data set for detecting like where these defects are as well. But I still think, well, you could use a transformer-based thing like DETR, so DETR, yeah, DETR. But you could also start with a CNN. It feels like a task that CNNs should be good enough at, actually. YOLO, maybe even. Try YOLO. If you have the bounding boxes, why not YOLO it? Yeah.
Okay, Jonas. Thank you so much. Someone has a question. His hand is up, and his name is Daniel. Man is up. Yeah, so I want to ask, in Africa and Nigeria, we are not this community guys. All we do is like go to YouTube, go to Udemy, go to Coursera, and we pay for courses, and we learn, and we start applying for jobs. Like we applied to 50 jobs and get 50 rejections. We don't believe. Most people I know don't believe in community. They just stay inside their room and lock themselves up and work, code, and then apply for 100 jobs and then get one acceptance and go for the interview and fail and come back. But since I started community, since I started doing this community stuff, I've gotten a lot of things come to me without even applying for them, a whole bunch of them. Even the job I'm currently doing, it was community. So I want to ask you, because I think you guys in Hugging Face, you guys are bad. You guys are really good. I remember the session I had, the session we had with what is her name? That woman, that your friend, the one from France. The one that,
Isabella.
yeah, Isabella. Like that was about computer vision. It was interesting. But we only know Hugging Face to go and clone models. We just go there and clone models and get out. So I want to ask you this question. How can we be really, really active in Hugging Face? What can we do to be really, really active and be known out there? We want to be part of the community, I was part of the community, but I was kicked out. Because, I was kicked out. So I used to post our boot camps there every day. I'll just go and they like deleted me. I use another email and log in. So that's by the way, anyways. So how can we be active in the community? Hugging Face, especially. Yeah, we act as boss here. Our Hugging Face boss. We want to be like you.
Well, I have to say I wasn't that active in the community, or feel like I wasn't that active in the Hugging Face community this year. But yeah, I mean, the Discord is always a good start. Actually, there's this Discord server by Hugging Face. You can join it. I think there's also some invite here. Yeah, if you just go here, I think this is like the invite thing. Yeah, and then you can just go to the Hugging Face Discord. You see, there's like a lot of members, a lot of online people. There
Wow.
are a lot of channels. I do advise you to not just take all the roles to see all the channels. Just really take the roles for channels that interest you. So if you're into computer, if you're open source in general stuff, then you get like these channels. If you're into, I don't know, data sets or whatever, yeah, you have to really filter out, because it's a bit of a problem that it is so big. There's just too much stuff happening. It's hard to keep up. Yeah. Also for me, yeah, I've got family. I've got 2 children. I can't read like Discord every 10 minutes. It's not possible. But yeah, so Discord channel is a pretty cool way to get involved. There are these reading group sessions. I think you can just, if you want to present something, a paper or whatever, some cool stuff you heard about, you can just say like, hey, I want to do a reading group on this topic, and then they will schedule it for you on some Saturday, I think, and you can do that. We also have, like, now I have to advertise it, we have our community computer vision course, right, which basically was my, I don't want to say stupid idea, but actually, I mean, it was a pretty cool idea, because there is this page here. It's called Learn on the Hugging Face website, right? And they've got all these courses, and they're like NLP course, deep reinforcement learning, audio course, open source cookbook, ML for games, and everything. But they did not have computer vision course until like the beginning of this year. So in April, actually, we released that. So last year I said like, hey, community, let's build a course ourselves. And if it's good enough, we can release it on Hugging Face on the website, right? And that's what we did. And now we've got it here. Actually, we haven't updated in a while because there's a problem in the pipeline right now for updating. But it is pretty cool, because everything you see in this course was not written by some Hugging Face employee. It was written by a community member, or by more than one community member, right? It's big, right? And the repository, actually, it lives in my GitHub, right? That's my computer vision course repo. And if you have some topic you want to write about, and actually writing about a topic is the best way of learning about the topic, right? If you're like, yeah, maybe I write about this, but I'm not sure if I know it well enough, just start writing something about it. And in the process, you probably will learn, right? Because we've got a lot of stuff you can write about. Basically anything you want related to computer vision, and we will find a place for it. And you can either create an issue here, for example, and say, hey, I want to write about this or that, or you can just straight up create a pull request. If you don't know how to do that, we've got a how-to somewhere around here. Contributing. Here's a markdown. If you read that, you will know how to contribute, and you can do that, right? So that's one way of being active in the community. Yeah, there are many more ways. Just stick around in Discord. Yeah, see for yourself.
Wow, that's nice. Good news. I'm in the community back. I just tried it and it worked. Yeah.
That's great. That's great, then. Yeah.
I'm back. Like, I was so stubborn. I was just posting things to I think the admin got me, was like, hey, stop posting those things. And I sent it. I sent an half line like, hey, get out of here. Kick me out. Yeah, guys, and in January, we're gonna have a boot camp, computer vision boot camp, 1 month through to building startup ideas. And Jonas is our key speaker. He's our key, is a 1 month boot camp, is our key mentor. So the course he just showed to you is the course we are going to use, and we are going to add some deep neural networks and some projects to it. So the link will be out soon. Get ready to learn and to build things. That is it. Jonas, man, you're a man of wisdom.
Thank you. Thank you.
Yeah, a man of wisdom, I swear. Like, you know a lot of things. Oh, you want to ask another question? Ah, God. Time is going. I don't want to take questions again.
I mean, you can also ask me afterwards if you want, like
Okay.
in
If
WhatsApp
you're
or whatever.
if you're just ask your question and Oak for the last time, please. Please. If you're Oak, just ask. We are gonna come back to if you're
All right. All right. Thank you very much.
Okay.
Hook, please ask your question.
Jonas, I really
Okay, your hands is
enjoyed the
down.
presentation. So
I think the connection is bad.
let me just go straight to the point. So yeah, my question is my question is and the disadvantage in terms of challenge of using large language model in production. So my question, hello, can you hear me? All right. So my question is this: is the advent of large language model aspect like computation and all those stuff, or is it that deep learning and all those stuff are still relevant in the market? Is away all those stuffs? Thank you.
Okay, if I understood that right, the connection was a bit shaky again. The question is about whether like computer vision or other stuff that's not LLMs is still relevant in the market.
No,
That,
no, no. So
no.
he asked, so everything you showed is about like, models, YOLO and the rest. So he's asking if deep learning is still being used because you have not talked about deep learning. Meanwhile, deep learning is actually what is used to build those models. So that's what he's asking.
Okay, yeah. Yeah. So it is relevant. I mean that's also as Daniel said before, like even with convolutional neural networks, people might tell you like convolutional neural networks who's using that, and there's actually a lot of people using that out there. That's like, I mean, that's always in tech, there's always errors for something, right? The same with programming languages. Who's using programming languages like Kobo or something, Fortran, whatever? There are still people using like ancient programming languages, and there's always stuff sticking around, and Daniel knows about the languages. So see, I don't feel old anymore now that Daniel McMullen said he just say all the.
He knows about everything, bro.
You are very welcome.
He knows about Kobo. Like this guy can.
And yeah, I mean, deep learning is really relevant. I mean, deep learning is just everything we do to build these models and everything. So yeah, I always see people like asking on Reddit or whatever, hey, should I still learn machine learning? Like, should I study that? I feel like everything is already done, or LLMs will do everything in the future. Of course, you should still study it. Of course, you should still look into it because it's important to understand that stuff. And yeah, it's not done. It's not the end of research when we have an LLM that can chat with us, right? So there's so much more to do. It might not always look like that when you're just reading one hype message after another, but there's a lot of work to do.
Yeah, for me, I feel people are like, should we still learn machine learning? Should we still learn deep learning? And they fail to understand that the models you're using right now was written off of machine learning and deep learning. All of them, all the YOLO, ResNet, the rest of them, they are all deep neural networks. Deep neural networks. But the thing here is, the company that if you are not going to care about learning all those things if you just want to just build one AI project and run away. But if you have a plan of working for a big tech company, you have a plan of working for Google, you have a plan of working with YOLO, Ultralytics, you have a plan of working with TensorFlow, and you want to build things, bro, you've got to know about deep neural networks. In fact, from the math, you have to know about linear regression. Need to know about linear regression and logistic regressions from scratch, like from pure math, from vectors metrics. You have to know about everything. Even in 2001 million, even in 2050, 2001 megabytes, you need to know about it. Because the companies that are building these models, the companies that are building this thing out there, they don't hire people that can use YOLO. They don't hire people that can use TensorFlow. They don't hire people that can use PyTorch. They hire people that can write PyTorch. People that can write it from maths, from calculus, from gradient descent. Those are the guys that are needed in the industry to build mad things, and not people that can use those things. Get what I'm saying? So that you explicitly need to learn. In fact, your assignment is to go and start learning calculus. Buy K-Stroy, that big math book, read it, finish everything before you start neural networks, and then you do machine. You enjoy it, because when one of the jobs I was doing, they brought me a very old code from MIT, old like ages, and they were like, "Bro, fix this code. I want you to detect someone's face." I was like the TensorFlow model used is very old. Like the model used to write the facial record deep. You know about Dilip, right? They brought Dilip for me to debug. Dilip, of all things. I had to crack it down, like get into a library, change some things. I didn't even install a latest version. I had to like write everything up again from landmark detection. And if I didn't do little mathematics and some basic things, I'll be lost, So that is it actually. That is it. Do we have any other question? I think time is gone. We are just enjoying ourselves here. Tools change, but the fundamental ways remain the same. That's the one advice I'll give people. Yeah, sure, that's true. The tools change, but fundamental is the same. Exactly the same. Just like people say, I'm not going to learn C++ and C. Like, oh, really? But as time goes on, you discover that most of the things run on an embedded systems, and those things are written with C, C++. You know. Guy, you want to ask a question again, John?
It's
Okay,
my
John.
question, sorry. Just that I'm trying to join the Discord channel and it's just telling me some crash that the invitation link is expired, I guess.
Can you?
Trying, yeah,
Okay.
trying to join the Discord channel, but it's saying it looks like this invite link is expired and
Don't
I
worry.
wouldn't be able to.
Let me send you a link. Do you have a link, Jonas?
Yeah, I think you can. Let me just check. I think they've got this thingy. Yeah, yeah. If you just copy this one into your browser, I think that should be valid.
Yeah,
Okay.
just copy.
They're
Can,
just generating like a invite link from this. If you if you just visit this URL
Okay.
that I posted, they just generate like your invite link, and that should be up to date.
Oh, okay. Okay. Thank you.
yo, guys, thank you so much. I would have gone ahead to ask like what have we learned, but man, I can't ask again. I'm tired. I want to. I'm trying, guys. I'm actually trying to learn fast API. I'm trying to learn fast API. I want to learn how to write APIs for my AI models. Like and I write Flask right now. I write Flask for my AI models, but I want to learn. I hate fast API is very fast. So I want to learn it so I can write my backend for my AI models from scratch or for all startups I'm trying to build, because I don't want to depend on people to build anything I want to build, except if I have someone that has the same mindset. So our next speaker is experienced, 40 years plus of tech knowledge. And he's going to talk about tech from the 80s to how we got here. And then next up is going to be our Python bootcamp. We'll be having issues organizing the speakers, like just organizing speakers. We have been fighting, but don't worry, we are gonna settle it up. And then that's gonna be before December, and we are gonna run it for 1 month. And then January 1st or first week of January, we are gonna start a boot camp, and all our speakers, all our um tutors are very, very experienced. Number one is Jonas. Jonas is very experienced. And we have Isabel. Isabel is part of the Hugging Face community. She's a professor. She's very good. We have Tariq. Tariq is from India. Sorry, it's from Pakistan. He's a professor, he's a researcher in AI. And we have Felix. Felix is from Ghana, he's a YouTuber, he's a computer vision engineer. He's very, very good. Felix Sam Nano, he just joined right now. He's a late comer. And then me, I'm not going to give the little my little knowledge. I'll teach about how to print hello. Print hello in computer vision. Maybe do a little of open CV and get out and disappear. Like so my so my bosses will take over. But Jonas, I really, really want to appreciate you for coming to, like, bro. Thank you for believing in Africa. I was surprised when I spoke to you about Computer Vision Africa in Ghana, and you were like, "Yeah, I'm going to join. I'm going to speak." I was really surprised. Like, you know, in the tech industry, we know people to be very proud. You know, when someone knows a little, it's gonna be like, "How much are you gonna pay me to teach? How much are I going to do this?" Then if you tell them to come and speak, they'll be like, "I'm too busy. I have holiday tomorrow. My holiday is next week." You cast someone, if you plan after 2 weeks. It's like I was on holiday. Like, you're on holiday, social media holiday, really? So are you on WhatsApp holiday or LinkedIn holiday? You plan after like 1 month, it's like, I went on vacation. People do a whole lot. But I was surprised that you had to speak to us. I'm really grateful for everything you've shared. And I'm going to watch the video over and over again. And I'll try to read those old research papers because I think there will be a lot of things that I need to know about. Please, guys, I want you guys to post these sessions, post it, talk about it. Um, Make sure you mention me, please. I want to see that you've posted. You mention me, it's going to show on my notification that someone has posted it. Or you can mention Computer Vision Africa. Once you do it, I'll see it too. Thank you so much. I really appreciate you guys. The session has been recorded, everything from up to down, and I'm going to post it on our YouTube channel, and you can go and watch it again. Jonas, it's a day for us. Thank you so much. I really appreciate you. All right. I love you so much.
Thank you, Daniel.
Guys, please post it to go and post it on your social media. Post the session. See you guys later. Bye.
All right. Have a good evening.
Bye.
Bye.